Good morning, learners and the fellow grade 12 tutoring campaign. I am Mr. Lucky Klaba, your mathematics teacher, and today would be looking at functions and graphs. Under functions and graphs, we have different types of functions. But prior to that, let's understand that there are certain graphs which are not functions. For a graph to be a function, there should be one value of y, which is an output, for every one value of x, or for many values of x. So for a function to take place, there should be one-to-one relation or many-to-one relation. If such a graph meets that requirement, then it becomes known as a function. However, if it is not, say it is one-to-many, so it's now not categorized as a function. And for it, of course, to be a function, we use what is known as a vertical line test. We use a vertical line test where we draw a vertical line and it has to touch at one point. If that is the case, then we call that a function. So under different types of functions that you should have studied up to your matric, you should have studied that we have a linear function, what is known as a straight line function. With a linear function, or what we come to call it a straight line function, first thing we need to know the general formula of the straight line. And the general formula of a straight line is that y is equal to mx plus c. So that is the equation of a straight line, y is equal to mx plus c, whereby by now we know that the m is the gradient of the graph. So we either have a positive gradient for an increasing function or a negative gradient for a decreasing function. And the m, to calculate m, we have it in our formula sheet, which is y2 minus y1 all over x2 minus x1. And of course, your c is your y-intercept. That is your straight line. And for us to draw it, we need the x-intercept as well as the y-intercept. Please remember, grade 12s, for x-intercept, we say our y should be equal to 0. And for y-intercept, the x should be equal to 0. So that is the first type of function that you should have studied, which is a linear function, okay? And in terms of the domain and the range, for this one, it takes all the values of x and it takes all the values of y. So as a result, our domain becomes X is an element of real number, and our range Y is an element of real number. Okay. Then we also have a parabola, okay, or is known as a quadratic function. It has a general formula: Y is equals to A X squared plus BX, okay, like a quadratic formula, AX squared plus BX plus C. That is the standard or the general formula for our parabola, okay? However, this can also be rewritten in a different format. I think you already know that it can also be written as A is equals to, it can also be written as A is equal to X plus P, okay, squared plus Q. All right, so that can also be written in this format, that is by completing the square. Of course, our P and Q are our asymptotes. The P is our vertical asymptote and the Q is our horizontal asymptote. So that is the general formula. And under parabola, things that we have to remember: one, we have to know where is going to intercept the x-axis. We also have to know its turning point, okay? We also have to know whether that turning point is a minimum turning point or it's a maximum turning point, okay? And of course, the value of A determines the shape of the graph, okay? So whether it's gonna be concave up or it's going to be concave down. That is about a parabola or quadratic function. We also have the hyperbolic function. With hyperbolic function, what now happens is that it has a general formula. The general formula of hyperbolic function is that y is equal to a into x plus p. Then on the side here, we've got plus q, okay? And also in this, the value of A is going to determine at which quadrants are we going to draw our hyperbolic function, okay? If value of A is positive, we usually say it's gonna be on the first and the third quadrant. But those quadrants are not necessarily the ones which are done by the Cartesian plane, but instead the quadrants are the ones which are done by our asymptotes. So our horizontal asymptote and a vertical asymptote, which is in this case our P, okay, for vertical asymptote, and the Q for horizontal asymptote, this one would be the one determining for us, okay, as to which quadrant are we going to have. All right, so that is your exponential function, hyperbolic function, mean to say. Then we also have an exponential function. With exponential function, okay, with exponential function now, what you have its general formula. Okay, on this one, before I get to exponential, hyperbolic, after you now know the quadrant, you know where you are going to draw your graph at, you get your x-intercept, your y-intercept, and it also have two axes of symmetry, okay? We have an axis of symmetry with a positive gradient. We also have an axis of symmetry with a negative gradient. All right. Then we have also the exponential function. So the general formula for exponential function is that y is equal to a, okay, b, then x plus p, x plus p plus q. So that is your exponential function. So it has only one asymptote, which is your horizontal asymptote. Y is equals to q. All right. So remember, asymptote is that imaginary line that our graph is going to approach, but it would never touch. So remember, our graph should never touch our asymptote. And we have an inverse function. So inverse function, now what do? We swap the x and y. If we are asked to write an inverse function, we swap the x and y. We just have to remember that the inverse now it's written as f, okay? It's written as f to the exponent of minus 1. So that is our inverse. So remember, with inverse, you swap the x and y, then you get your inverse. And of course, your graph and its inverse are symmetrical about the line y is equals to x. So that is very important, you know, that the inverse. So you've got different inverses for different functions. But something important, not all inverse of a function is also a function. At times, the inverse of a function is never a function. Okay, so it's important that you know when the inverse is going to be a function and when it's not going to be a function. All right, so now let's get some of the important information on the things which would be examined and the things which are not examinable. We have the following, okay, guided by examination guideline. A candidate must be able to use and interpret functional notation. In the teaching process, learners must be able to understand how f at x has been transformed to generate f at minus x. Okay, so I think you know when now it becomes minus x, that's when we are talking about reflection. Okay, so it has been reflected about the y-axis. So it's important that you know what happens when it's reflected about y-axis. It becomes f at minus x. When it becomes minus of f at x, it has been reflected about the x-axis. Okay, so the y then becomes negative. Then we know when x, it has been added a. Okay, when a is being added, we know our graph has been moved either to the left or to the right. So if it is minus, it has been moved to the right. If it is plus, it has been moved to the left. And f at x plus a, when the a is on the other end now, it means our graph has been moved. If it's plus, it has been moved certain units upward. If it is minus, it has been moved certain units downward. And of course, when a is multiplying f at x, in this particular case, our graph now is being multiplied by a certain factor. Okay, and it's important that one notes that the trigonometric function will only be examined in paper 2. So under these functions, we are only going to be looking at the 5 functions I mentioned, which are the one examined under paper 1. Let's now move to the format of the paper. I shared this with you last time, so I'm not going to go deep into it, but for your information, just do remember that the functions and graph, it gives us good amount of marks. So it's part of paper 1, so it's going to give us good amount of marks. So to check how many marks are we going to get, let's see the weightings of the paper. Under weightings, you can see that functions and graphs are going to give or take 35 marks. So functions and graph, they are going to give us give or take 35 marks. So it is very important that we make sure that we get the maximum marks from that topic. Okay, so it's about 35 marks. you can easily score good marks on it. All right, now let's see how we can now go about this. But before then, just as a reminder, please do read instruction and information. It's important that you answer all the questions, you number as it's numbered in the question paper, you show all the calculations, diagrams, graphs, and remember, answers will not necessarily be awarded full marks, okay? And do use your approved scientific calculator, and rounding off, if necessary, should be done to 2 decimal places, unless, of course, it's stated otherwise, okay? And the diagrams that we should see are not necessarily drawn to scale, okay? And of course, it's in your best interest to write neatly and legibly, okay? And last, the information sheet would be given to you towards the end of the question paper. Make sure you make use of the information sheet. Make sure you use the information sheet. Now let's look at how the typical question would look like. Let's see how a typical question would look like. All right. So there is the question. They say the graph of f at x. There is the graph of f at x. It's written f. That is our graph of f at x. Okay, is equals to a half open bracket x plus 2 close bracket squared minus 8. Okay, and we are also given f at x. Where is f at x? There is our f at x, which is g. We've got f at x, also g at x. Okay, on the same set of x's. Okay, so one is a straight line. I think you can see g is a straight line, and your f is the parabola. Okay, your f is parabola, and they gave you the turning point. There is your turning point, okay, at point A. So we've got turning point at point A, and you've got C to be the point of intersection of the two graphs, okay, and it also happened to be the y-intercept. Right, we also have the axis of symmetry of f, which passes through E. Okay, then point D have unknown coordinates, which is m and n. Okay, I would like to think examiner might want us to know what would be the coordinate of m and n. Okay, and C is the y-intercept for both. Okay, so let's see after this information has been given, how the question appears. Make sure that you read the problem statement thoroughly. Try to compare the information that you see in the diagram, okay, together with the information given in a problem statement. From there, consolidate those information together. Then it would be very easy for you then to answer the question. Okay, it would then be very easy for you to answer the question. Okay, now let's look at the first question. Okay, so the first question on the next slide, let's see what it says. The first question say, write down the coordinates of A. We need to know what is A before we can write the coordinate. Okay, so let's check. There is A. Remember, A is a turning point. Okay, so because A is a turning point, and we have this graph given in this format, so we know that this would be our x at the turning point, and this is going to be our y at the turning point, the P and the Q. Okay, so it means therefore this is the P and this is our Q. Okay, I'm highlighting it for you so as it come easy. This is our Q, and this of course is our P. Okay, so we've got the P and the Q. And remember, if it is plus, it has to be minus, and if it was minus, then it's gonna be plus. So now the coordinates, then it becomes easy. Okay, then it becomes easy to get the coordinates. it becomes easy to get the coordinate. Okay, so now maybe to make it even more easier for you guys, let's write the equation given to us. Okay, let's write the equation given to us. So it's our equation, okay, in a different format, of course. Okay, so there is our equation. There is our equation. It should be minus. I see I wrote plus, so it should be minus. So there it is. Then we minus 8. So if we want to get the turning point, which is A, then the coordinate of A would be as follows. A would be minus 5. Okay. Minus 5 is 2 minus 8. Okay. So that's the coordinate of a turning point. And where did I get the minus 5? You can say x plus 5 is equals to 0. Then you get the x to be minus 5. That's your x, that's your y. The y, you get it from here. Okay. So then it becomes very easy. So that was our 4.2.1. Okay. 4.2.1. Okay. So let's look at the other question. What do they want? On the other question, they want us to get the range. Okay. First, we have to understand what is range. Are the values of y where our graph exists. Okay. So we need to look at the values of y where our graph exists. So let's check here. When you check here, our y values, they start from here, the turning point, and they go all the way up. Okay. So the y values, they start here at the turning point, they go all the way up. So it means the graph, in our graph, the values of y which exist, they exist at the y at the turning point if we move up. So it's any number which is greater or at least equal to the y at the turning point. As a result, then what would be the solution? The solution would be that let me go to the solution slide. Okay. The solution therefore would be that our y, it's 4.2.2. Our y is gonna be greater or equal to minus 8. To say any value equal to minus 8 or greater than that, that's where our graph exists. Okay. But I know others, you are using a different notation. Okay. Others, I know you are using a different notation. Okay. If you're using that different notation, it would be where you would say y is an element, okay, of a square bracket. It means we include minus 8. Okay. We go all the way to infinity. Okay, and be careful of the bracket. So y is an element of minus 8, including it all the way to infinity. So yes, that would be how you get the second question, the range. Okay, they did not ask us about the domain, but if they can choose to ask us about the domain of this graph, we're gonna say x is an element of real numbers, to say it takes all the values of x. Okay, so let's look at the next question. What does it require of us? Okay, so please remember this is our graph that we are working on. Okay, so the next question wants us the values of m and n. Let's see where this m and n are. Remember I said unto you likely examiner would ask us to get the value of m and n. And as it is, there it is. We are requested to get m and n. But at point D, which is the point that we want, already we have one coordinate. You see, at point D, we already have one coordinate. We know the x at this point. The x at point D, okay, the x at point D, there it is the same as the x at point E, which is the same as the x at point A, because it's in one line. So praise ourselves, already we've got the value of m. Easy, the value of m is the x at E and the x at A. And we know the x at A to be minus 5. So as it is, we now know what will be our m. The m would be the same as the x at point A, which is minus 5. So the only thing that we do not have, it will be our n, all right? But at least if we have one coordinate, we can substitute where the point pass. So the point passed through a straight line. So we're going to substitute the equation in the equation of a straight line, okay? So now let's see how it should be done. The m and n for 3 marks, okay? So the m and n for 3 marks. So now let's look at it. It's 4.2.3. Okay, so we just said that the m is going to be equal to minus 5, which is the x at point A, because they share the same x. But now for us to get the n, we have this equation, which is y is equal to a half of minus 5, okay, plus 9 over 2, okay. So we substituted this from equation of a straight line, all right. So remember the straight line was y is equal to half, okay, it was half x, okay, but x now has been substituted to be what? Minus 5, okay, all over 2. Then that is our given equation of a straight line. So now the y becomes the n, okay, the y becomes the n, and after you substitute the y being the n, now you have to get to the solution. If you do that, you find that your n is going to be equal to 2, okay, the n is going to be equal to 2. So that point that we want, its coordinate is minus 5 is to minus 5 to 2, okay. So that is the coordinate of D, the point that we want. It was easy. So we had x from knowing that it shared the point with the x at turning point. Then we got our y by substituting on the equation of a straight line. That is where that point pass. Okay. So yes, that is how you were supposed to get the m and the n. Now let's look at the other question. On the other question, they want us the area of OCDE. Okay. Every time you are asked to calculate an area, not only here in paper 1, even perhaps in paper 2, you need to know the figure that you want to get its area, what type of the figure that is. Okay, so let me go to the graph, try to see what type of the figure this is. So they want the area of CDEO. Okay, aha. So now look, there is the C, okay, there is O. So this is the area that they want, okay, they want this area. So if they want this area, let's take the shape, okay, let's look at the shape. Already I can see it's a quadrilateral. So if it's a quadrilateral, I see that two parallel sides, okay, parallel but not equal. So from here already, I can tell this is a trapezium. Remember, under your quadrilaterals, there is a trapezium, okay? So which has a parallel lines and not necessarily equal. So those two parallel lines, they tell me that this is a what? A trapezium. So now, because I discovered it's a trapezium, now I'm going to calculate the area of a trapezium. Okay? Remember the area of a trapezium, a half sum of two parallel lines. These are the parallel lines. For information, these are the parallel lines. Okay? These are the parallel lines. So it's a sum of half sum of parallel lines, then multiply by the distance between them. Okay? So that would be how we work it out, the height between them. Okay. So now let's get the formula. Okay. Let me get a clean sheet to work on. So now let's get the area of a trapezium. Okay. So the area of a trapezium in our case is gonna be a half. Okay. Which is DE plus OC. DE plus OC when it's multiplied by OE. Okay. And all this length we have, let's check. We have half, then we've got our DE. Okay. We've got our DE. Our DE it's 2. Okay. Our DE is 2. Let me take you back so as you can see where the 2 come from. Our DE, there is our DE. Our DE is 2 because of the value of n. Remember, we just calculated that n is 2. So the DE would be that value of n, which is 2. Okay. And OC, okay, OC, the value of C here, remember it's a straight line. So this 9/2 in here, okay, the 9/2 here is our C, and in here it's also C, so it's our y-intercept. So that value, which is 9/2 or 4.5, it's our OC. Okay, then we are going to multiply by the distance height between them, which is OD. So OE rather, OE is from here to here. So which is the value from here to here, and that value it's 5. So remember the value here is 5, the value here is going to be 2, the value here is going to be 4,5, which is 9/2. Okay. So now we can calculate our area. So we can substitute those values. I've shown you how to get them. So it is 2, and OC it's 4.5, which is 9/2, the y-intercept, right? And OE, the distance between, it's 5. Okay. All right. So that is how you are going to get it. Then you work it out with your calculator. Of course, you are going to get 16.25. That would be your answer, 16.25 units squared. So that is your area. Okay. So that is how to get the area of a trapezium. Our figure was a trapezium. Okay. So now let's go to, I think it's the second last question. Yes. So let's go to the second last question. So they say, determine the equation of g minus 1, which is the inverse, okay, in the form y is equals to. Remember I said when you get the inverse, you swap the x and the y. Then you make a y subject of the formula, okay? So you swap the x and y, then you make y a subject of the formula, okay? So now, let's create space for us. So now let's say, what is the original equation? Okay, so we've got the original equation which we are going to swap. So the equation, it's y is equal to half, okay, x plus 9/2. So for an inverse, we swap this x and y. So where I see y, I now put x. Okay, then it's 1 all over y. Okay, you are going to get the mark of that over 9/2. Okay. Now we have everything set. So now the last part of this is to make a y a subject of the formula. When you make y a subject of formula, y is going to be equal to, remember, you have to take 9/2 to the other side, it becomes negative. Then you are going to cross multiply. Ultimately, it's going to work out to 2x. Okay, it's going to work out to 2x minus 9. All right, it's going to work out to 2x minus 9. That is how you were supposed to get the inverse. That's your inverse function, swapping x and y. Okay, so let's look at our last question. If h of x is equal to g minus 1, okay, which is the inverse of x plus k, it's a tangent. Okay, so they tell us that graph is a tangent. So you see they've just added k to the inverse. Okay, determine the coordinates of a point of contact between h and f. So they want the point of contact between h and x. Okay, h and f. So if they want us to have a point of contact, what they want of us basically, it's easy. Okay, what they want of us, it's easy, because we know that it's a tangent. Okay, because we know that it's a tangent, so that tangent, we can either use a derivative. Okay, but I know some of you might be struggling with how to get a derivative. Okay, so might be struggling with how to get a derivative. Rather, I'm going to show you how to simply do it, because they want the point of contact. So the point of contact is whereby those graphs are equal. Okay, the point of contact or the point of intersection is where the graphs are equal. So you can equate the graphs. Okay, so I'm going to take that method. I think it's more easier. Okay, so I'm going to take that method. It's more easier. Okay, so now there is our graph. So I'm going to take f at x. By the way, that is a level 4 question. Okay, f at x. Then f at x, I equate it to h at x. Okay, I equate it to h at x. So as I equate the graphs, it's going to be half. Okay, it's going to be half x minus 5, x minus 5 squared minus 8. Okay, so there should be plus 5. Then the h at x, we have the h at x. Okay, we have the h at x. that is going to be this function, okay? This function, which is 2x, the inverse, 2x minus 9. But remember, they said plus k. So you put k. So this is our inverse plus k. Okay, you make an inverse plus k. After you make an inverse plus k, all right, so this is going to work out to half, when you multiply everything out, x squared, okay, half x squared plus 3x plus 3x plus 27 all over, okay, plus 27 all over 2 minus k is equal to 0. Okay, after you do that, now it becomes simple. Okay, you can get your x, okay, you can get your x and you can get your y, all right, by remembering the following. Nature of the roots, I think you remember, minus 4 AC, okay, is equal to 0, okay, for equal roots. Okay, so you can get your x this way. Okay, so remember, for equal roots, this will be the case. Then you get that your x would be equal to minus 3. Okay, your x would be equal to minus 3. When you substitute that equation, then your y is going to be equal to minus 6. So the point that they want is minus 3. Okay, minus 3 is to minus 6. Okay, so that would be your answer to this question. All right, so yeah, it was a level 4 question. It was not quite easy, I must agree. So yes, that's how you'd get your answer. All right, and yes, you can look at this for a home activity. That is another graph that you can look for yourself. It's an exponential graph. Okay, it's an exponential graph. You can take a screenshot. So that is your exponential graph. Okay, and these are the questions associated with that exponential graph. You can also take a screenshot of this. These are the home activity. Okay, and yes, we have come to the end of our lesson for today. Yes, it was on functions and graphs. I hope you have learned a lot through that. And if you do not have any questions from your end, that would be the end of the lesson for today. And I thank you.